3-wire plus ground feed from a UPS without an output transformer should not be distributed. The primary reason is the absence of a ground reference for the output when the UPS is operating on battery power. This condition arises because there is no output transformer to establish a neutral to ground bond. In a typical electrical system, the neutral conductor is intentionally grounded at the service entrance. This grounding provides a return path for fault currents, allowing overcurrent protection devices like circuit breakers and fuses to quickly interrupt the circuit in the event of a ground fault. Without this ground reference, a ground fault on one of the phase conductors might not create a sufficient current imbalance to trip the overcurrent protection. Imagine a scenario where one of the phase conductors comes into contact with a grounded object, like a metal enclosure. Because there's no established ground reference, the current flow through the fault might be limited by the impedance of the fault path and the UPS inverter. This limited current, while still potentially dangerous, may not be high enough to activate the circuit breaker. This situation presents a significant safety hazard. Personnel touching the grounded object could be exposed to a dangerous voltage, leading to electrical shock. Additionally, the uncontrolled fault current can cause equipment damage and potentially ignite a fire. The function of a transformer in a UPS is multifaceted. Firstly, it provides isolation between the input and output circuits. This isolation helps to protect connected equipment from voltage spikes and other power quality disturbances on the input side. Secondly, a transformer can be used to step up or step down the voltage to match the requirements of the connected load. Thirdly, and most importantly in this context, the transformer allows for the creation of a bonded neutral to ground system on the output. This bonded neutral to ground provides the necessary reference for proper operation of overcurrent protection devices. When a ground fault occurs in a system with a bonded neutral to ground, the fault current flows back to the source through the grounding conductor. This large current flow causes the circuit breaker to trip, quickly disconnecting the faulty circuit and preventing electrical shock or fire. UPS systems that are designed for distribution typically include an output transformer to provide this critical grounding function. These transformers can be configured in various ways, such as delta Y or YY, depending on the specific requirements of the application. The key is that the transformer creates a neutral point that can be bonded to ground, ensuring proper operation of overcurrent protection devices. If a UPS lacks an output transformer and is intended for a 3-wire plus ground distribution system, it is essential to ensure that the system is properly grounded using an alternative method. One common approach is to use a separately derived system with a grounding electrode conductor connected to a grounding electrode. This grounding electrode provides a low impedance path to ground, allowing fault currents to flow and trip the overcurrent protection devices. It is important to consult with a qualified electrical engineer or electrician to determine the appropriate grounding method for a specific UPS installation. They can assess the specific requirements of the application and ensure that the system meets all applicable codes and standards. Attempting to distribute power from a UPS without proper grounding can create a serious safety hazard and should be avoided. Always prioritize safety and consult with qualified professionals when dealing with electrical systems. When selecting a UPS, consider the specific requirements of the application and choose a model that is designed for the intended use. If the UPS is intended to provide power to a distribution system, ensure that it includes an output transformer or that an alternative grounding method is implemented to provide a proper ground reference. Understanding the importance of grounding in electrical systems is crucial for ensuring safety and preventing electrical hazards. Grounding provides a path for fault currents to flow back to the source, allowing overcurrent protection devices to quickly disconnect the circuit and prevent electrical shock or fire. Without proper grounding, electrical systems can become dangerous and pose a significant risk to personnel and equipment. Always consult with qualified professionals when designing, installing, or maintaining electrical systems to ensure that they are properly grounded and meet all applicable codes and standards. Consider the impedance of the grounding path, as a high impedance path can limit fault current and prevent overcurrent devices from operating effectively. Regularly inspect grounding connections to ensure that they are tight and free from corrosion. Grounding electrodes should be installed in accordance with applicable codes and standards. By following these guidelines, you can help to ensure the safety and reliability of electrical systems. In the described scenario, distributing the 3-wire plus ground feed from the UPS without an output transformer is not recommended due to the lack of a ground reference. This can lead to hazardous conditions and should be avoided. The grounding system should be carefully evaluated and properly implemented to ensure the safety of personnel and equipment. Therefore, the concern about not distributing this type of UPS output is valid and should be heeded to ensure electrical safety. The absence of a transformer leads to a floating ground condition, which makes detecting ground faults difficult and potentially dangerous. In addition, it's essential to remember that national and local electrical codes, such as the National Electrical Code, have specific requirements for grounding electrical systems. These codes are designed to ensure safety and prevent electrical hazards. Ignoring these codes can result in serious consequences, including fines, penalties, and potential liability for damages. When working with UPS systems, it's important to follow the manufacturer's instructions and recommendations carefully. The manufacturer will provide specific guidance on how to properly install and ground the UPS system. It's also important to have a qualified electrician perform the installation to ensure that it meets all applicable codes and standards. Regular maintenance and testing of the UPS system is also essential to ensure its continued safe and reliable operation. This includes checking the grounding connections, testing the overcurrent protection devices, and inspecting the batteries. By following these guidelines, you can help to ensure that the UPS system provides reliable power protection without creating any safety hazards. In summary, the absence of an output transformer in a UPS with a 3-wire plus ground output necessitates careful consideration of grounding. Without a transformer, the system lacks a readily available ground reference, which can compromise the effectiveness of overcurrent protection devices and increase the risk of electrical shock. Consulting with qualified electrical professionals is crucial to determine the appropriate grounding method and ensure compliance with applicable codes and standards. The focus should always be on safety and ensuring that the electrical system provides reliable power protection without creating any hazards. Also, it is important to remember that UPS systems are designed to provide power during outages. While they are generally reliable, they are not foolproof. It's important to have a backup plan in case the UPS system fails. This could include a generator or another source of power. It's also important to regularly test the UPS system to ensure that it is functioning properly. This includes testing the batteries and the overcurrent protection devices. By following these precautions, you can help to ensure that your critical equipment remains powered during outages. Furthermore, UPS systems come in various sizes and configurations, and the choice depends on the load requirements and desired runtime. A small UPS might be sufficient for a single computer, while a larger UPS might be needed for a server room or an entire building. The runtime of a UPS is determined by the battery capacity and the load connected to it. A larger battery will provide a longer runtime, but it will also be more expensive. The load connected to the UPS should be carefully calculated to ensure that the UPS can provide sufficient power for the desired runtime. Overloading a UPS can damage the batteries and reduce its lifespan. UPS systems also have different levels of protection against power quality problems. Some UPS systems only provide basic surge protection, while others provide more advanced protection against voltage sags, voltage swells, and harmonic distortion. The type of protection needed depends on the sensitivity of the equipment connected to the UPS. Equipment that is sensitive to power quality problems, such as medical equipment or scientific instruments, will require a UPS with more advanced protection features. Installing a UPS system is a relatively straightforward process, but it should be done by a qualified electrician. The electrician will ensure that the UPS is properly grounded and connected to the electrical system. The electrician will also configure the UPS to meet the specific requirements of the application. Regular maintenance of a UPS system is essential to ensure its continued safe and reliable operation. This includes checking the batteries, cleaning the UPS, and testing the overcurrent protection devices. The batteries in a UPS system will eventually need to be replaced. The lifespan of the batteries depends on the type of battery and the operating conditions. It's important to replace the batteries before they fail to avoid downtime. By following these guidelines, you can help to ensure that your UPS system provides reliable power protection for many years. Finally, remember that electrical safety is paramount. Always disconnect power before working on electrical equipment. Wear appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, but by following safety precautions, you can work safely and avoid accidents. So, in the specific case presented, it is important not to distribute the 3-wire plus ground output without an output transformer. The risk of undetectable ground faults is too high, potentially leading to dangerous situations for both personnel and equipment. Proper grounding is critical, and a qualified electrician should be consulted to ensure a safe and compliant installation.